Hello, everyone, and thank you for attending today's webinar, Standardize Your Telco Cloud to Accelerate, Assure, and Automate, sponsored by Juniper and Red Hat. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type them into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Toward the end of today's presentation, we will ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading Senior Analyst James Crawshaw. James?
Thanks, Morgan. Hello and welcome everybody to this light reading webinar about standardizing Telco Cloud, presented by Juniper Networks and Red Hat. As Morgan said, my name is James Crawshaw and I'm an analyst with Heavy Reading, and I'm joined today by Pierre Bichon, Product Manager for Telco Cloud Solutions with Juniper Networks, and Rob Wilmoth, Chief Architect for North America Service Providers with Red Hat. I'll start with a brief introduction before handing over to Pierre to talk about some of the challenges of systems integration for NFV infrastructure. He'll also talk about the coexistence of containers and VMs, and Pierre, together with Rob, will discuss how they have come together with their Contrail integration and Red Hat OpenShift offering. We'll wrap up with some key takeaways and have around 15 minutes at the end for audience Q&A. So as we go through the presentation today, if you do think of a question, please submit it via that Q&A tab. So service providers are busy building the telco cloud, and they're doing that to support initiatives like network virtualization. They're also doing it to modernize their IT estate and to enable new services like 5G network slicing, edge computing, and massive IoT. But a lack of in-house skills is often hampering service providers' ability to deploy and manage the telco cloud because, frankly, it's hugely complex. There are multiple components from different vendors, and integrating them all is proving to be quite a headache. Now, a stopgap measure that some operators have taken is to use a vertically integrated stack of VNF, Virtual Infrastructure Manager, and NFV infrastructure from each particular VNF vendor. But that is not going to deliver the CapEx efficiency or the common Vim and compute underlay that NFV promised. On top of that, the complexity of testing and deploying updates to VNFs, VIMs, and NFVI needs a whole new set of CI/CD tools and a DevOps culture, which a lot of operators are lacking today. So, with that as the background, let's start off with our first audience question poll of the day to test your pulse, see what you're thinking. What do you think is the biggest challenge in building the telco cloud? Is it about integrating the various components from multiple suppliers? Do you think it's about identifying which supplier is responsible for resolving problems, so avoiding the sort of finger-pointing issue? Is it more about getting containers and virtual machines to run in the same environment? Or do you think the biggest challenge is getting vendors to containerize their applications? Whilst you have a think about your answer to that, just another reminder that we do have 15 minutes or so at the end of the webinar today for audience Q&A. So as we go through the presentations, if you think of a question, please type it into that Q&A widget. Okay, let's see what our audience have voted for. I can do a quick update in a moment, but it looks like the most popular choice that's coming out is this issue about integrating components from multiple suppliers. There's a bit of concern about finger pointing. There's some concern about getting containers and VMs to run in the same environment. But it's this integration challenge, Pierre, that people are picking up on. Is that what you found as well when you're talking to your service provider contacts?
Yeah, that's very much true, and that's what we are trying to address. In fact, this complexity of integration is really something that people have been struggling for in the last few years, and there are now things that are getting better, and we have new solutions to apply. So that's where our focus is, and because most of our customers actually are asking themselves the best way. What's the best way to address that? That's definitely yeah.
Okay, good. Well, with that, Pierre, let's hand over to you to take us through the next section of the presentation.
Yeah, thank you, James, for the introduction. So yeah, that's was setting the scene very well, and I want to also step back a little bit on why we talk about Telco Cloud and this complexity of integration, and it comes into a background of where the telcos are evolving to implement 5G networks, and that's a major step, and everyone talks about 5G these days, and that's because 5G has really a potential to tether any type of end user, from humans, machines, or software applications, and really deliver gigabits of bandwidth with potentially very low latency over the air. So this opens up a whole new set of revenue-generating products and services that can be offered by the telcos. And what is different with 5G compared to 4G is that really 4G was a big architecture change, and telcos have made their first steps in cloud in 5G. In 4G, sorry. But 4G only really offered nothing more than higher bandwidth. So now with 5G, it's really time for telcos to take advantage of cloud networking to really turn these new services into something profitable and take advantage of the capabilities that 5G brings. And bringing the cloud technology to leverage that is something really new and really the right time for telcos to apply cloud technologies. So telcos, in fact, they have the real estate to deploy the new services all across their network. They just need to add clouds, in fact. So when we talk about Telco Cloud, it's not just about new technology. When we think about using cloud to transform the business of the telcos, it's quite intuitive to think that it's about investing in both expertise and technology to achieve the cloud outcomes. And the promises of cloud, in that case, are more around agility, flexibility, the scale, to lower the TCO sometimes, to shorten the life cycles, and to have a better time to market. And these cloud outcomes can produce tangible savings in terms of time and revenue, and they can still make us more responsive to customer demands and market opportunities. So investing in people and technology alone can be a waste of money without investing in the processes to automate the cloud. So automation is really something quite important, because if you look at Google and Amazon, they are not successful just because they are virtualized their environments. They are successful because they build an entire automation framework based on DevOps principles, which gives them the efficiency and the economies of scale. So people, technology, processes. Cloud is really a pod with three legs, and the seat is worthless unless you have all three. So why is this important for this audience today? Well, it's because everybody here is building or planning to build clouds, and these clouds will leverage the valued physical footprint of the existing service provider, which is the data center itself, a POP, CO, central office, aggregation and pre-aggregation real estate, which is in use today. And where you build the clouds, the number of clouds and the distribution of those clouds, this will be dependent on the latency sensitivity and also the compute demands of the applications and the services that you want to offer over the network. So it's a when, in fact, not really an if, that you will operate many clouds, and those clouds will progressively become more and more distributed over time toward the edge of the network. But what do I mean here when I talk about an edge cloud, really? and maybe I need to switch to the next slides. Most telcos have built data center clouds. A few clouds, typically centralized, but now they start to be distributed to edge clouds. So what is the makeup of an edge cloud, really? And you see on that picture that an edge cloud is much more than just virtualization technologies. It is the intersection of two evolutions which are currently happening. And the first evolution is that we disaggregate the existing edge telco platforms into an intelligent and programmable fabric of switches, leaf and spine switches, in combination with data center gateways and security, so that you end up with a plug-and-play model of orchestrated service nodes, compute, storage, and services. And those service nodes will be a combination of physical functions, VNFs, and also CNFs. The second evolution is the adoption of edge computing, where the placement of the cloud infrastructure will be physically moved closer to the end user, to the machine, or the application. So the Telco Cloud data center expands towards the edge clouds. So a key takeaway is that the edge, at the point where we deliver the service, will coexist in many locations within the network. And unlike legacy networks where the edge was a fixed location, the Evolve Cloud Edge will be dynamically assigned to the most appropriate and most cost-effective edge location based on the application requirements. And this is important because the cost of compute increases the further it is distributed. So those applications that don't require ultra low latency or drive huge bandwidth would be better served in a more central DC, while an application leveraging, for example, 4K video for an augmented reality service would need to be just a few milliseconds away from the consumer. So we know that 80% of the TCO of a network is in OpEx. So there are clear actions we can take to reduce that cost. First, to create universal edge cloud architecture that's capable of running any and all services, whether they are infrastructure services or revenue-generating services in the same location. And second is to leverage automation and the principles around DevOps. And this is what I will develop further, because we can illustrate the importance of automation, especially at edge clouds. Say here you have a single cloud with an IP fabric which connects your service edge. Here, in this example, we have 2 DC gateways, 2 spine switches, and 2 leaf switches. 6 devices in total. Your operations team could manage this and likely use scripts to help streamline operations. It's not a big deal. However, if you start to multiply those edge clouds, the complexity and the cost of managing the network follow with the n-square curve with each new location. So as you increase the distribution, you end up managing fleets of clouds. And this is where the cost of cloud technology can totally undermine your expected cloud outcomes around reduced cost. And when you overlay the number of VMs with a higher number of containers driven by a microservices-based cloud-native environment, the need for automation starts to gel completely. Let's have a look further at the complexity to integrate telco edge cloud then. So to see what problem we face really. So an edge cloud and a telco cloud in general will be composed of a variety of subsystems, each one having its own life cycle. What I mean by life cycle here is a major and minor release with new features, bug fixes, security patches, etc. So all these subsystems in the edge cloud are first of all, the NFV infrastructure, which is composed of the operating system, typically Linux, and the virtualization stacks, such as OpenStack, the SDN layer, the monitoring of all this, and then the underlying servers with their NICs, smart NICs, eventually, and FPGAs, GPUs, storage, all integrated by an IP fabric made of switches. So on top of the NAVI, each of the VNFs that rely on it has its own life cycle. and release management, and also evolve from virtual machines to containers at a different pace. So you end up having many different types of VNFs and CNFs which consume the same NFVI, and they all consume at different rhythm and pace. And many of these subsystems typically come from various vendors. So, and as we have seen as well, in a distributed edge cloud scenario, you have multiple types of sites with different combinations of all the above elements, and over which many workloads are deployed. So it means in such a telco cloud, all those subsystems need to be tested to make sure that they work all together and that any update of one subsystem doesn't break anything in the others, of course. So because of the number of test permutations become also infinite here, this is way too complex to be performed with traditional tools like scripting or even manual or GUI-based systems. So what can we do about that? And what do we do about that, right, as Juniper? First of all, we are a networking company, so which took about, the last 20 years to drive the network industry. And this experience has landed in an automated deployment solution called Contrail Edge Cloud that lets you start with a centralized cloud deployment and use that centralized management to cost-effectively distribute cloud compute without to have to replicate all the virtualization infrastructure management into each location. So that reduces the server capex, the space and power, and obviously operational cost. So the virtualized network is tightly integrated with the existing telco network where MPLS and BGP shine, and it leverages the routing expertise of Juniper. The second thing that we can do about it is that we are using our self-driving networking principles to automate cloud management. This includes AI-based telemetry and analytics with AppFormix, which is now called Contrail Insight. And we have added Contrail's Fabric Manager and a CI/CD pipeline framework to that. And finally, at Juniper, well, software development and distribution and support has been our primary business for over 20 years, beyond hardware platforms. So we have leveraged this software expertise to package up a completely integrated telco cloud solution that's easy to design, to implement, and operate. So that's called Contrail Cloud. That we have worked with our partner Red Hat here to take all the lifecycle spaghetti of self-integration that we have seen, and we have packaged it into a pre-integrated horizontal cloud stack that you can run universally throughout the network, including up to the edge cloud. Let's first look a little bit at our experience in networking, our core experience, in fact. So telco clouds, and in particular edge clouds, are about deploying VNFs, containers, and physical devices. And they need to be interconnected over the telco wide array network. A VNF, in fact, is made typically of not just one VM or one container, but of a cluster of VMs on servers that are interconnected together as a system to perform the role that the VNF is supposed to play. Right? It's not just a single element, but a combination of different elements that talk together. So scaling out such VNFs require a flexible overlay networking layer, which is what Contrail SDN brings. Otherwise, you end up having to create your interconnection relatively manually with VLANs and physical ports of servers connected to switches, and it becomes quickly very difficult to manage manually. In a horizontal telco cloud, several VNFs also need to connect together in a chain to deliver a service. And they typically connect to multiple other systems as well, which are in multiple virtual networks as well. So the SDN automated networking brings a lot of flexibility and in the operations. And in an edge cloud, VNFs are deployed at the edge sites also, and they are typically smaller in footprint, but still need to scale out in many dimensions and also interconnect to each other together and have the different elements and interconnect to each other, and also with the central VNFs. Because what we do in those VNFs is that they can typically, and more this is going to be the case, that the VNFs can be extended using control and user plane separation principles or CUPs. This means that part of the VNF is now extended over remote sites on remote compute nodes. The service is delivered over the wide area network of the telco and typically over a particular slice of our virtual network. So there are many such slides and virtual networks that span across the telco wide area network. And Contrail is very flexible and powerful SDN networking that provides services such as BGP as a service to the VNFs, and that automates the deployment of the disaggregated VNFs at the scale that the telcos require. So obviously, while we evolve towards cloud native and containers, that will amplify the need of flexible networking, because there will be many more containers than VMs. And still, both VMs and containers will coexist for a while. And Contrail provides the automation networking glue between the VNFs, the CNFs, and also the PNFs. In addition to that, the construction of clouds at the edge means that applications can now be deployed at the edge to deliver a service. And here, for example, a connected vehicle service. So this service is made of an entire ecosystem of applications that need to coexist and share the network. They need to connect to each other at the edge and also to their own central sites. In addition to that, part of the applications may leverage public clouds. This means that the telco edge cloud is in reality more than just a telco cloud. It's a multi-cloud, which is multi-tenant, and as such needs to be completely secure. So let's talk about the second aspect of the capabilities that we can bring to solve the complexity of system integration. Let's talk a bit about automation. James mentioned CI/CD, and it's true that it's part of a continuous evolution that all the virtualized infrastructure are seeing. And it's true that we talked about automation for a long time. It has been used for some time already in telco cloud deployments. However, it's been mainly based on scripting, even with high-level languages, to support the deployment itself, not really the life cycle itself. It's better than manual, of course, but it's not efficient enough, so notably for edge clouds, as we have seen. Right? So DevOps and CI/CD technologies are the only possible way today to solve such a complex problem and provide an integrated lifecycle management of so complex stacks as we are under a continuous evolution here. So CI/CD imposes to start by structuring all the resources that make the network and the cloud infrastructure as objects, which are called artifacts. And they are source codes, binary files, inventories, configuration, test suites, a lot of components. This is a declarative way of defining the entire infrastructure. It's called infrastructure as code. And this is the foundation of the CI/CD process. CI/CD means constant integration and constant deployment, or continuous integration and continuous deployment, whatever you want. And the first step, which is the CI, is about integrating the various source codes and configuration files that we have seen into a build that goes through a series of tests, which are called by one or several integration pipelines. which is a suite of actions that are chained together. The second step, continuous deployment, takes a fully integrated and tested software and automates its deployment over the network. And also it monitors it over time. The CI/CD system is interesting in the sense that it provides a revision control and automatic rollback capabilities, meaning that if there is a failure at some point in the pipeline, it's very easy to roll back to a previously stable configuration. So that anything that is breaking actually something in the pipeline does not really harm, because you can quickly come back to a stable situation. So this is a new way of thinking how we build networks and clouds, where the deployment is fully automated through those pipelines, where it's possible to test and upgrade just one component of the NAV stack, for example, as well. You don't need to upgrade the entire system. You don't have to test for 3 months and wait for a maintenance window. The upgrades can be made almost daily available as soon as the code is ready. And the network finally is monitored continuously so that issues are identified and corrected quickly. Right? This methodology of CI/CD allows to be much more flexible and fast to deliver new services over an entire telco cloud infrastructure, and it has the power of improving the overall quality as well, and reduce the cost through the entire life cycle, not just for the deployments. And when you consider the evolution of telco clouds towards cloud native, which will be made of a myriad of microservices, well, the complexity is such that only CI/CD technologies can address the complexity of managing the lifecycle of all those microservices at the scale and the level of SLA that service providers require. So finally, what we do with Juniper and in partnership with Red Hat, and in investing in automation tools like CI/CD, we move to an intent-based declarative model where we describe what we want to achieve. The pipeline then manages the files that drive configuration changes into the network and test the change that need to be run for the expected behavior. So this is in contrast of an imperative model, which describes the how to achieve the desired outcome, and would be equal to running a script that brings you from state A to B, but doesn't build any progressive automation or automatic change management. So using the CI/CD pipeline along with a pre-integrated stack like Contrail Cloud allows service providers to shift their operations resources from managing the cloud infrastructure itself to focusing the resources on things actually that matter, like really building revenue-generating applications and services to drive the business, which is, and this is on top of the NAV infrastructure that it relies on. So this improves the reliability by using automation to reduce manual errors that could be very costly when managing a cloud fleet over an entire network. And ultimately, it makes the business more efficient by reducing the time to market and assure that the products and services delivered are actually intersecting with the customer requirements and what the market demands. So maybe Rob, maybe we can see in more detail how the Contrail Cloud stack is pre-integrated between our two companies to deliver what I've been, all the promises I've been talking about. So Rob, up to you.
But before that, Pierre, I think we've got one more audience question poll, which is, how would you best describe your current telco cloud projects? Would you describe them as, and we're missing labels here, so this is A, B, C, and then D, E, F. So A company initiative driven by a specific VNF use case, such as IMS or EPC, or is it B, a company-driven strategic investment, no specific use case, or is it C, a departmental level investment, driving separate cloud architectures? And here are some other combinations. It could be both A and B, the first two responses, or B and C, the second and third, or all three, A, B, and C. So I'll give you a few moments to think about your answer to that. It's a slightly tricky question. And once again, remind the audience that we'll have time for Q&A with the audience. So as we get into Rob's section coming up next, if there are any questions that came to mind from what Pierre was presenting, then please type in a question. Let's see what our audience have made of that question. Quite a tricky one, I think. So the biggest response is A and B together. And then the next biggest response is just A, company initiative driven by a specific use case. And then the next greatest response is A, B, and C all together. So I guess what I could infer from this is that of those first three use cases, of those first three responses, the first one, the company initiative driven by a specific VNF use case, that's the standout winner. That's the clear winner. And I guess if you look then at the next two, it's a little bit hard to unpick. Pierre, was this a question that you came up with, or Rob, was this one of yours?
I think it was raised when we were thinking of how telcos are actually triggering their initiatives for NAVI deployments. And in fact, we have seen those three different ways of thinking. And to be honest, in the recent past, mainly with the 4G environments, a lot of emphasis has been put on the virtual EPC, virtualizing the EPC, and then building an NAVI for that. And also quickly, the IMS has took over. So it has been very well the case that is highlighted in the first line here, first option. And now we see more an evolution towards thinking about the infrastructure to be ready to accept some new VNFs. And more importantly nowadays is how this NAV infrastructure will allow to evolve the applications and the network functions toward cloud native, toward containers. That's really the focus. So it's more like horizontal thinking, and that's where it's really about thinking for the entire company to deliver the right infrastructure that will be there for some time, and to deliver quickly, in fact, as well.
Great. Okay, well, thank you for that additional color, Pierre. That helps. With that, let's pass the mic to Rob Wilmoth, Chief Architect for North America Service Providers at Red Hat. Rob, over to you.
Thanks, James, and thanks, Pierre, for setting up all of the promises that I get to explain how we all uphold together. So moving right along, within this architecture, Red Hat OpenStack platform functions as the virtual infrastructure manager of them, allowing applications, in this particular case Contrail, to run seamlessly along with other VNF applications inside of a common architecture. This starts speaking to the horizontal nature that Pierre was alluding to earlier. And in the poll question, I found it actually very interesting that a lot of the work is use case specific. One of the things that I'll caution everybody on is that when you start looking at a specific use case with a specific vendor in mind, if they're not also embracing the concept of a horizontal architecture, it can lead to concepts that involve vendor lock-in. So in this particular example, Red Hat distributes the load amongst different workers, leveraging Contrail for the SDN and also enveloping them as a certified ecosystem partner for the Red Hat OpenStack platform. This enables the full benefits of being on Red Hat to be inherited by Contrail, such as upgradability, security, and expansion to additional public cloud offerings as needed. We can see in this diagram where the actual Contrail pieces reside. We still leverage the parts that make Red Hat great, our commitment to align with upstream technologies as well as other certified partners, so that your telco solutions are capable of meeting targets as needed. Furthermore, we base the solution on Red Hat Enterprise Linux, which allows us to leverage the management frameworks, automation, and security methodologies that have made the underlying OS such a staple in today's data centers, as well as the expansion out to the edge. Furthermore, this promotes a horizontal architecture where you're able to innovate outside of the constraints of a single vendor verticalized stack. For those looking for containerization, we do have a solution for you as well. In this scenario, we have OpenStack Platform 13 with OpenShift running nested inside of it. This allows for a solution where OpenStack Director is being used as a virtualized hardware provisioning agent for OpenShift. In this specific example, we're still able to leverage Contrail as the SVN for OSP, or OpenStack Platform, and OpenShift inherits these capabilities as they are provisioned by OpenStack and managed by Juniper. This specific scenario also helps a service provider get around some of the inherent multi-virtual device to single physical device mapping challenges presented when trying to run an expanded 5G type VNF in a containerized infrastructure. You may still have to take into account potential impacts of running nested or complexities with performance and network mapping via floating IPs, for example. It becomes important in a nested fashion to ensure that OpenStack and the orchestration going into it are configured correctly from the beginning so that you're not making massive changes once you've already deployed and are working within OpenShift. Red Hat and Juniper are both aligned and positioned to help with these architectural conversations as well as the deployments that come afterward. So what exactly helps us work together within OpenShift? It's the fact that within Red Hat's offering, there's around 198 different packages that get installed with the OpenShift product offering. You as the operator can actually choose which of these pieces you want to use from Red Hat or which pieces you want from any of our certified offering partners, and these can be utilized for their specific functions and use cases. The benefit from this aspect is that while Juniper is working with their technologies to support advanced use cases, that they are uniquely qualified to support within our service provider customers as well as our other partners. While Juniper does this, Red Hat provides a stable OpenShift platform that marries directly to upstream community releases, continually integrating them for a production-ready enterprise release about every 3 to 4 months. We're also doing sub-releases that allow for backported changes and fixes to keep your environment running and ready with minimal downtime. As part of these integrations, OpenShift provides Contrail exposed CNIs based on open standards that help avoid lock-in and choose best of breed as needed throughout your environment. The beauty of this is that it allows you to work closer to the edge and bring centralized operations to an expanding and more complex environment. This diagram shows where the different portions of OpenShift continue to be replaced by the Juniper solutions, such as vRouter and Contrail Kube Manager, to ensure that API requests that come in make it back to the Contrail controller in an appropriate and timely fashion. Red Hat also provides automation technologies for the deployment and provisioning of our technologies, and our partners such as Juniper are able to take advantage of these features as they see fit. This can come via Ansible networking modules which speak netconf, SSH, or other scripted languages that we leverage to build provisioning scripts to keep everything together. The upside is that we use the same technology for deployment that you're able to customize for your own applications or other vendor solutions to make up your full stack. We've tested this in many different use cases and have expertise in-house to both define your automation and provisioning strategy, but also work alongside both your organization as well as Juniper to ensure a consistent flow of mentorship, ensuring that your automation is as close to one-touch or zero-touch as possible. Today, Red Hat is actually working to ensure that the technologies such as Ansible and OpenShift are able to leverage AI/ML to enhance and broaden the capabilities, decrease the complexity necessary to manage such a solution, and ensure that your day 2 operations teams understand what's going on in the environment. Going faster really only works well if you're going faster in the correct direction. Red Hat has been the market leader in infrastructure as a service for many years now, starting with OpenShift, OpenStack, and now OpenShift, with many of our automation and orchestration technologies supporting. The source of this market leadership is the innovation driven from our open source upstream communities combined with a stable base of Red Hat Enterprise Linux. We've been working directly with our service provider customers to ensure that their needs and use cases are met, as well as providing assurance that public cloud remains an integrated option for cloud-native and multi-cloud workloads. We provide the aforementioned technologies in conjunction with automation portfolio, including CloudForms, Ansible, and Satellite, in order to allow for orchestration, day 2 management, and compliance and security all the way out to the edge. Pierre, do you want to talk a little bit about the value that Juniper provides that really makes this a 1 + 1 = 3 solution?
Yeah, thanks, Rob. And in fact, what we bring is actually we enhance this entire solution that you bring for the NAV structure, and really bring the SDN layer, which is in fact something that the market has accepted very well. We are very deployed and the most deployed commercial SDN layer stack in the market. And notably with telcos, and where we leverage our footprint and experience of the telco world through the networking capabilities, and we bring complementary offering to the Red Hat stack with Contrail networking, the Contrail security as well, which is a unique combination to bring both networking and security, which is very good to address all the challenges of building a secure NAVI stack. We also have AppFormix for service level assurance, and now named Contrail Insight, and we have a number of VNFs, virtualized platforms like Virtual MX, which can bring a few virtual routing capabilities, and Virtual SRX, which is about virtual security. So we have we are complementing the Red Hat stack, and we integrate that, as you have seen, nicely to, and we test it, we pre-test it before we ship to customers. So we have processes that I was mentioning at the beginning between our two companies, so that when it comes to implementing at the customer side, I mean, a lot of things have already been done. So you have a faster time to market to just deploy new clouds, new edge clouds, notably, and also to solve problems. So it's the combination of the two is more easy to design first and to deploy and to operate mainly. And both of our companies, and notably Juniper, have a very strong commitment to develop open source technologies. Juniper has started to be in the SDN market with being open source from the beginning. We started with Open Contrail, and now it has been renamed as Tungsten Fabric, which is now part of the Linux Foundation. And under this umbrella, it evolves with its own life and with contributions. And I think both our companies are very much committed to that. And it's true that when you look at the telco cloud market now, there is a lot of focus on making sure that the solutions and the horizontal stacks that are deployed are based on open source components, so that to avoid the lock-in that was previously the rule in vertically integrated stacks. So that summarizes our partnership, and probably, James, you want to lead us to some other final comments or polls?
Yes, that's right, Pierre. We have time for one last audience question poll. What primary approach has been taken to build your Telco Cloud NFVI environment today? Would you describe it as self-integrated, vendor integrated, something that a systems integrator has put together for you, or was it pre-integrated, perhaps one of these vertical stacks we talked about earlier? I'll give you a few moments to put out your response, and then after that, I'll give some brief takeaways, and then we'll move into audience Q&A. So if you haven't done so already, please submit a question via that Q&A tab at the bottom of your screen. Okay, let's see what we've got. So we've got a mix of responses here. The most popular response is a vendor-integrated solution, followed by a solution that was put together using a systems integrator, and a small number, around 10% or so, indicated it was self-integrated. So is that in line with what you see typically in the market, Pierre and Rob? The sort of roughly half is vendor-integrated solutions, roughly half have been put together with the help of a systems integrator, and only a small minority are self-integrated by the operator themselves. Is that a typical response you'd see?
Yeah, from the Red Hat side, I think this is fairly common. The vendor-integrated solutions do carry the benefit of having the one throat to choke type model. However, a lot of the differentiation comes from proprietary solutions that what we found in the lessons learned from OpenStack is that a lot of the proprietary nature ends up being developed and innovated in the upstream anyway. And so we're able to pull that technology down in a very rapid fashion and help people not only catch up with, but surpass some of the vendor-integrated solutions with the horizontal stack. As far as the self-integrated piece, that one we're seeing more and more often. And it's almost as though there's a pendulum that swings from a fully vendor-integrated solution to the complete opposite end of a DIY model, where the actual service provider is going out to the upstream, downloading Kubernetes and building their entire platform, or downloading KVM or OpenStack, building their own platform and trying to integrate it. We're seeing less and less of that when you get into containerization, because while there is a openstack.org that pulls together all of the different projects that you need to make it work, with Kubernetes and with containerization, you don't necessarily have that already pre-built and readily defined. So we're seeing the pendulum swing back a little bit more toward the center, and that's where we see the system integrator or the pre-integrated solutions really start taking hold and providing a lot of value.
Great. Okay, thanks for that additional color, Rob. That brings us to our takeaways, our conclusions. I think what we heard today is that the pre-integration of NFVI and Vim with a CI/CD tooling is really paramount to automating the Telco Cloud. And we've heard from Juniper and Red Hat about how they've collaborated to create Contrail Cloud, which is this pre-integrated OpenStack-based Telco Cloud offering, and it brings about a simplification in the cloud design, the deployment, and ongoing operations. It's very much a horizontal solution, so it's supporting multiple VNFs on a common Vim and NFVI. I think you could also describe it as a turnkey solution, so that leads to a faster time to market, faster service design and lifecycle management. And overall, I think it's about simplification of operations with DevOps processes and open source tools for CI/CD, testing and maintenance all in one place. So with that, let's move into the audience Q&A session. If you haven't done so already, please feel free to submit a question via that Q&A tab at the bottom of the screen. Let's start off with this one. Somebody's asking about, we hear a lot about cloud native, but does that mean that you need a whole new cloud platform? Rob, perhaps you want to have a stab at that first.
Sure thing. So I think it really depends on whether you're trying to take a full-blown CNCF or OpenFog approach, or if you're just trying to act within the spirit of the orchestration and automation necessary to be cloud native and beyond that cloud aware with your application stack. Within the telco service providers, most of the technologies that exist are able to be made cloud aware or cloud enabled in a virtualized or containerized footprint. So you really only have to work within the constraints of those two types of environments. I do a bit of work in the cable operator space and also in the Tier 2 and Tier 3 service providers. And what we're finding is that some of the technologies that exist there may or may not lend themselves to being virtualized or containerized very easily. So you end up having these service chains, and Pierre did a good job of speaking about them earlier, where you may actually have physical devices that only speak a certain language as part of your cloud-native architecture. So do you need a whole new cloud? Not necessarily. Do you need to augment the cloud you have and beef up the automation? Absolutely.
Okay, interesting. We've got another question here is, you talked about pre-integrated versus self-integrated cloud stacks. What do the majority of your customers do today? So Pierre, perhaps you could take a stab at that. Pre-integrated versus self-integrated. And just for my benefit, if you could clarify the difference once more.
Yes. A lot of our customers in the early days, a few years ago, started to self-integrate, meaning that they take all the pieces of the NAV infrastructure and they want to do the integration themselves. For example, they will take the Linux operating system, the OpenStack, the SDN, and then we'll put the servers, put everything on the servers. They will manage, of course, the connectivity of the different servers together. And then once they have reached that state where they have an NAV infrastructure, then they integrate the VNFs on top of it. So that's the self-integration, and of course that is mainly about doing a systems integration work, where some service providers are good at, and some are a bit less experienced in doing so, because it's mainly about dealing with new technologies, very much open source technologies, and things which evolve very fast, in fact. It's true that it has been a very important step for them to learn, and in fact the whole industry has learned a lot by doing all this integration, this self-integration, and mistakes have been made and lessons have been learned. Okay. Now, one of the lessons that I see from our customers who started to do that is that they consider that it's very costly to do this self-integration themselves. They need to manage also the relationship between the different parties, the different vendors. And I have tried to explain that there are many parties potentially. I mean, just between we often with Red Hat have projects where we have to work together for a customer, but we have also companies involved, typically the server vendor, very much the NIC vendor as well, especially if there are SmartNICs in the picture. And we have also very often companies like Intel who provide the underlying infrastructure of the server. So there are a lot of companies that need to work together, and the service provider has learned that it is challenging, and there is a lot of effort to be done to do that, and they now consider that they may not do the same when it comes to the cloud native era that we are just entering at the moment. And it's gonna become more complicated. They tend to want to simplify all this process. Maybe not just to have a single entity which is doing all the system integration for them, but at least to have some part of the entire stack that needs to be integrated and deliver to them. So that's what we call the pre-integration. We pre-integrate with Red Hat here, and we deliver a stack that to the service provider, and then service provider can work with the VNF vendors to integrate and maybe do some integration work by themselves, but they want to simplify the number of companies that they have to deal with. It's becoming, very complex. So that's the two things. I mean, there's probably a trend to evolve from self-integrated to pre-integrated, at least to some level of the stack. Yeah.
Okay, thanks, Pierre. I've got time probably for one or two more questions, but before I go to those, I'm going to push out on your screens a survey form. This might appear as a new tab in your browser. There might be a pop-up blocker that you need to activate or deactivate in order to allow this survey tab to appear. And if possible, fill it out. Let us know what you liked about the webinar, what you'd like us to cover in future webinars. And whilst you do, I'm going to go back to Pierre and Rob and ask this question. It was in reference to the service assurance aspect that you mentioned, I think, Pierre, in the last slide where you were talking about the Telco Cloud partnership. And was it AppFormix you were referring to as being part of your assurance solution?
Yes, it is. It's now called Contrail Insights. Yes, we provide that solution that gives the visibility into the entire NAVI stack and gives ways to report and deliver service assurance capabilities. Having said that, we work with Red Hat to jointly deliver service assurance capabilities, and that can be also raised to overarching applications coming from third-party companies. And since we have a lot of, and by default we work with APIs. I mean, all of our systems are built using APIs extensively. Any functions, including these assurance functions, but all the SDN functions and the NAVI functions are typically called through APIs. That is very, very easy to integrate into an overarching service level assurance system. And maybe Rob, you may want to add on your view of this aspect.
No, I actually think you summed it up pretty well. The only piece that I would add is that Red Hat is leveraging the Juniper service assurance piece as well as combining it with some of our own capabilities that come out of Red Hat's middleware portfolio to apply some of the AIML to make everything sing harmoniously together, as opposed to some of the situations where you get certain assurance frameworks that may not be completely tightly integrated, let's say. So that's the only thing that I would add to what you'd said.
Great. Okay. Well, with that, we've got pretty much close to the top of the hour, so I think it's best we wrap it up and deal with any other questions offline. These slides are available to download from this website through the resources section. Feel free to reach out to the speakers today if you have follow-up questions. It just remains for me to thank Pierre Bichon from Juniper Networks and Rob Wilmoth from Red Hat, and of course thank our audience for listening in and participating in our question polls. Thank you very much and have a great day.